Hello everyone, and thank you for tuning into my talk. Today I'm going to talk to you about the Multipass open source hardware authentication ecosystem. My name is Mathieu Stephan. I'm an embedded systems engineer. I used to write for hackaday.com for 3 or 4 years, something like that. I also have a website full of open source projects, different ideas, funky projects I work on during my spare time that you may want to visit. And obviously I'm the Multipass project founder. So what is the Multipass ecosystem? The Multipass ecosystem is a complete ecosystem based around one or multiple hardware devices. It allows you to store credentials, logins and passwords, notes, and small files. It also allows you to authenticate using SSH or web authentication, also known as FIDO2. The device itself offers time-based one-time passwords. The device supports multiple users, so not only multiple users can use one device, but also one user can use multiple devices. We have a whole bunch of complete open source cross-platform tools for Windows, Linux, Mac OS, and we also offer native browser integration. What I mean by this is that basically you can just go to any website, and whenever you need to authenticate, the device will prompt you. You just need to approve on the clickable thumb wheel, and you will be seamlessly logged in. We are completely open source software and open source hardware. As I said, open source hardware. We have a whole bunch of contributors located all over the globe. Here you can see a map of the different contributors. I'm quite happy to see that evenly spread. It's quite nice. Multipass ecosystem. So here, I'm going to go through each of them. So the device itself can communicate over USB or Bluetooth. On the USB and Bluetooth communication channels, we offer the HID protocol, which is a big word to say we are just sending 64 bytes every millisecond that we are using to transfer data. So the device itself can actually type logins and passwords for you. So it's detected as an external keyboard on any computer, smartphone, iPad, or whatever. So it will type the different keys for in case you want to type a login or a password. It also has another communication channel, which is HID, that we use to send the more complex data. So typically, if you want to manage your database, or if you want to, change the device settings, this goes through our proprietary HID communication channel. So as I was mentioning before, we have open source software, open source applications that allows you to interface with the browsers in case you want to authenticate on websites. SSH authentication through the daemon as well, and command line based tools. We also have some software frameworks in case you want to script communication with the device. And also, we are currently working on some mobile applications for Android and iOS that allows you to make full use of the autofill framework. So that means that whenever you need to authenticate on your smartphone, on an app, or maybe on an app or on some application on the device itself, then you can directly see with this custom app, you can actually directly use the device without having to use credential recall, like by typing key presses. So from pictures to blocks, Multipass Hardware, the device that I mentioned, the latest is the Multipass Mini BL. What is also very interesting to mention is that we have a device emulator. So if you have Windows or Linux, you can actually install our emulator and use our complete ecosystem without having a hardware device. This is extremely neat because this allows you to test the ecosystem without having the device. We have a whole bunch of automated build scripts that takes the code from the device and bundles it into a software. So actually on your computer, you can have a Multipass Mini BL up and running and already try to log into website using the hardware emulator. It's extremely nice. So Multipass communicating to the daemon, to the command line tools, companions, SSH agent. Moving on, I'm going to start talking about the Multipass device, the Multipass hardware. The Multipass adventure started 7 years ago It started on Hacker Days in 2014. On the top left, you can see the Multipass standard, which was mostly a bit big for our users, but quite nice. I'm still using one as a desktop solution. Multipass Mini, and on the bottom right, the Multipass Mini BL. As its name implies, it offers Bluetooth communications, but also USB. The devices are made in aluminum. They are made to be tamper evident. So that means that our complete security model relies on the fact that if anyone wants to tamper with a device, it will leave some trace of some sort. So here you can see me trying to have fun at opening devices and see if actually this would leave a trace. It was actually quite fun. The latest model, Multipass Mini BL, we went a bit bananas, we went a bit overboard in such a way. What I mean by that is that we actually have two microcontrollers, two physical microcontrollers on the device itself. We have one that is solely dedicated to communicating with the outside world. Bottom part of the screen here, you have the auxiliary or unsafe microcontroller that is dedicated to communicating using USB or Bluetooth. As I'm sure you're aware, like every 2 or 3 weeks, there is a new flaw that is discovered on some chipsets and stuff or stuff like that. So basically here, we went on the safe way and we decided that anything that deals with communication interfaces will reside in the unsafe microcontroller. So like we really wanted to make sure that we were not taking any risks. So the auxiliary microcontroller deals with the communication. And then we have a main microcontroller, secure microcontroller, that deals with the rest, with the file storage on device, the graphics that you see here, communication with the smart card. We also have like a thumb wheel, clickable thumb wheel interface for the user to interact with the device, and then an OLED screen. Dual microcontroller, the communication between the main microcontroller and the auxiliary microcontroller is done using some old school fixed frame UART Link, which is really simple to prevent adding unnecessary complexity. All the complex libraries run on the auxiliary microcontroller, and everything that runs on the main microcontroller is created from the ground up with us, making sure also that making sure there is no major flaws with different kinds of analysis, and using open source to use the wisdom of the crowds. Data decryption flow. So the secure microcontroller basically is going to decrypt any data that is stored inside an external flash. So to get the decryption key to perform the decryption function, it is going to store that decryption key into a smart card. So the smart card basically stores your AES encryption key. The user enters the PIN code using the thumb wheel to the secure microcontroller. The PIN code is sent to the smart card. If the PIN is correct, then the AES key is retrieved from the smart card, sent to the secure microcontroller, and then whenever a credential or some data needs to be accessed, this goes through the auxiliary microcontroller. Microcontrollers are both microchip AT-SANDI21. They store the user profile data. That means, what I mean by that is that whenever you insert your own smart card that authenticates you, the microcontroller needs to recognize it is you, so there is some profile data that is stored internally inside the secure microcontroller. And we also store unique encryption and signing keys. So each device of each Multipass device has unique encryption keys. This allows us to make sure that not one signing key can be used to compromise a complete fleet of devices. So with that, we guarantee that not one critical point is going to affect the complete fleet of devices. So that means that we need to generate uniquely signed firmware updates. So you may wonder, how are we generating all these encryption keys and storing them to each microcontroller? Well, basically, we are flashing the microcontrollers ourselves. So we design a custom-made programming jig. And whenever we start a new mass production run, we spent a few days doing a pick-and-place machine, pressing buttons just to flash some uniquely generated encryption keys. Let's talk a bit more about the firmware features of our devices. So everything is coded from the ground up, except in cryptography routines. You never create your own cryptography. We are not pretending that we are good enough to generate that. So we are using the bare SSL library. We are using counter mode for encryption. Creator of the library is amazing, provided amazing support to make sure that we didn't have like we were doing that we were supposed to. We made sure that our routines were correctly done using NESI vector sets. All the data you're storing, all your logins, passwords, small files, notes, they are stored in an external flash. So there are two types of data, some credentials, web authentication, and encrypted blobs, which is small files and nodes. For the device, for the secure microcontroller, to go through them, we created our own linked list data structure. We didn't want to use any library because of the overhead, and we wanted to make sure we were as efficient as possible. So basically we created our own read-write linked list data structure. That also means that we handle multiple devices, multiple databases. So one device can store up to 100 databases, and so that means that 100 users can actually use one given device. So your complete family plus colleagues, whatever, could use one single device and use it to authenticate to different services. Smart card is just a read protected memory. We are currently in the process of migrating to a newer model. So basically, you present the PIN. If the PIN is correct, then you can access the secure storage. If you present an erroneous PIN 4 times in a row, then the card locks itself. So you may wonder what happens if you lose a smart card. Well, actually, on the device itself, we offer the possibility to clone your smart card. So every device is shipped with 2 smart cards. So in case you lose one smart card, you can still use the other to authenticate and to decrypt your complete credential database. It's fairly cheap and it's fairly convenient. Random number generator. We are using the onboard accelerometer. So the accelerometer provides 3 16-bits output words, and basically the last 4 least significant bits are basically like they do not represent anything. So of the 4, we're using the last 2 as a source of generating random numbers. We checked that actually that was valid using the hardware test and other tests, and it seems it's good enough. So we're fairly happy with this. USB and Bluetooth communication channels. We are using HID protocol. As I said, it's basically 64 bytes sent every millisecond. One is the keyboard, so that means that as the device is detected as an external keyboard, it will send bytes of data that represent characters. I'll get back to this later. So it can type anything to any device and any application. It's fairly neat. And there is the proprietary one, which is basically the thing that allows us to provide native integration into websites, native credential recall and stuff like that. Micro credential recall. So here I'm going to go a bit deeper in the details of how the keyboard protocol works. So basically, when your keyboard at home, it doesn't send characters to your computer. It sends some bytes. These bytes, so the bytes to character translation is done by operating system. This is your layout. So on your operating system, you can select, okay, my keyboard is actually French, or it is English, or whatever. So that means that the computer itself, whenever it sees the byte, I don't know, 32, it will translate it into an A or B. So that means that the device itself needs to know which byte to send for each character based on each layout. So that was quite fun to implement. So we passed the Unicode Common Local Data Repository. So big zip file full of files for each layout and all that. And we are basically passing all of these files in order to know which byte we need to send to the computer to type any login or password. It's quite fun. Web authentication, that was solely added by one single contributor. This is fairly neat. This is essentially a way to authenticate by generating public-private key partnership. It's also called FIDO2, successor of FIDO U2F. Website adoption is slowly in progress. So we implemented basic support. So FIDO2 It also has a whole bunch of like optional services that we are developing. So if you are interested in contributing to this to our ecosystem, we could use some help on adding the optional features of Fido. Graphics library. We have on the Multipass Mini BL, I think we have like a total of 1,000 graphical files on the Flash. These are used to make the smooth animations you see here on top. We designed that graphics library from the ground up, optimized for speed. We use run length encoding compression for the bitmaps. We support multiple fonts for the different languages. And non-contiguous character blocks. I would need to go a bit in details to explain a bit more about this, but let's skip it. So we have a dedicated data storage flash whose only purpose is to store all the different things I previously mentioned. The different bitmaps, the HID key presses to character lookup tables, the different strings, like you can actually change the device language on the device itself if any need, the firmware updates, and all of this bundle is CRC and CBC MAC checked using the unique encryption key of each device. Other noteworthy features, oops, sorry, I skipped that. We, as previously mentioned, we can change the language on the device. You can also change the device behavior. So when it comes to security, we all have our preferences. Some people prefer to be prompted whenever there is something that needs to be performed at the device, whenever you need to log in, whenever you want to change login passwords, like you may want to check what's happening. So here we are offering basically the option for the user to select his ease of use and security trade-off. So either you choose to be prompted for everything, or you basically trust the device and you let the device do everything that you need it to do. So like here on the device, you can choose this behavior, what is shown on the bottom right of the screen. You can, on the device, you can delete your profile, create new ones, clone smart cards. We have a whole bunch of different features, change the PIN code as well. Also, one new thing that we offer, we allow the tagging of different credentials with categories. So let's say that you have a whole bunch of credentials when you use it at home and a whole bunch of credentials when you use it at work. So you can tag each credential with the right category in such a way that when you go to work, you tell the device, okay, I'm at work, so please only offer credential recall of credentials that are tagged as work. So that's actually fairly convenient to have a reduced database whenever you go to different environments. We are using nickel metal hydride batteries because they have more charge and discharge cycles, also safer. That also meant we had to implement our own state of charge algorithm, which was very nice to implement. On the software side of things, so we talked about the device, now we're going to talk about the software. We're going to talk about Multiqt. Multiqt, this is a cross-platform Windows, Linux, macOS software that is based on a daemon and a GUI. This allows you to completely change the different settings of your device. As you can see here, like you can change the inactivity timers, the different the language, the layouts, like a whole bunch of settings you can change. All of these were actually asked by our customers, like by people who say, I would like the device to do this, and some of them actually contribute, make a pull request and offer that feature. And if we see that it makes sense, we also implement it. Like we're really listening to the people who want that device. We also have a credential management mode where you can visualize your device database. Here you can see, so this is taken using our emulator. Like here you can visualize the different services on your website. Different logins on each website. And here you can see the different categories, the description, logins, password, and all that stuff. So you can completely manage your device database with this one. You can rename the categories. We also offer note storage. So whenever you have like small sentences, Bitcoin recovery keys, all the different like critical data you want to text-based critical data you want to be stored, and here on the Multiqt software, you can actually store all of this. We also offer storage of small files. So small files, what I mean by small files is like a few kilobytes of data. It's not meant to store like large chunk of data. It's simple stuff. Like we are really aiming at offering critical data storage, not like, for example, also private keys. We also offer this. We also offer the software allows you to export and import databases from two different devices. And also one neat thing is that it also allows you to monitor one given backup file. So let's say that you have two devices, one at home and one at work, and you want to always maintain you always want to make sure that the database on each device is up to date. So the way you would typically do this is that you would store your backup file into like a cloud storage service and all that, so let's say Dropbox, whatever, and you will tell Multiqt to monitor that file. So that means whenever the database contains more credentials than the one on the device currently connected to your computer, you will be prompted to update your device. We also have an SSH agent, command line interface, and browser extension. Browser extensions, we have Chrome, Firefox, Opera, Edge, Safari. This allows you to natively, to seamlessly log in into any website. You go to github.com, the extension picks up the credential request, forwards it to Multiqt. Multiqt asks the device if it has any credentials, and it will prompt you to approve the credential request, and you will be seamlessly logged in. Just a click, or if you choose the device to be as in simple mode, it will just notify you that you're currently being logged. We have a command line tool, return in Go, which also allows you to recall credentials. We have an SSH agent, return in Go, which retrieves the private keys from the device. I would personally more recommend using FIDO2 web authentication to authenticate to different servers. Since I don't know which version of OpenSSH is possible, it works amazingly well. I highly recommend it. And we also have a Python framework. Let's say you want to interface with other device, you want to script anything. We have some files for you to get started in case you want to implement anything. Usually, typically, when this is also a good starting point for people who want to write, I don't know, some C-based application, because Python is easy to read and you can understand from the source code how it works. We also have very nice wikis with the different details about the protocol we selected. We are looking for contributors. We are spending quite a lot of time tagging the issues on GitHub in order to make sure that they are rightly flagged. For example, we have enhancement requests, we have new feature requests, we have bugs and all that. So basically, we are tagging every issue to make sure we have a good categorization of issues. We are currently migrating to a new smart card, as previously mentioned. If you want to be part of this adventure, just send me an email. And we also making new apps for iOS and Android in order to offer native credential recalls, and this is going to be actually quite nice. Basically, whenever we need to log in, when you need to log in into any app or any service on your phone, the service will query the multi-device device for credentials. So we will not need to use the device and tell it, okay, please type me my login and password for that service. So this will be all seamless. I'm really looking forward to that. So that's pretty much it for the talk. If you have any question, please, you can contact me on RSC. I'm always connected on rsc.libera.chat. We also have an RSC channel, which is Multipass. My email address can be seen here. The main organization repository is github.com/multipass. In it, you will find our application, our firmwares, a whole bunch of scripts. Really, we have a few things that you may be interested in checking out. So if you have any question, do not hesitate to ask me, and also don't hesitate to reach me in private.